Hello, I'm Jim Provost, a Senior Data Scientist at Lixar, and welcome to Real-Time Telemetry Processing. Lixar started off as a 4-man group in Ottawa in a basement and has grown to more than 200 people in Ottawa and Halifax and people across the country. Our 4 main verticals include enterprise mobile, data sciences, IoT, and cloud computing. Our main focuses for industries are air, automotive, telecommunications, and emerging technologies. As a Microsoft Triple Gold certified partner, we have the honor of attending conferences with Microsoft around the world. Recently at Microsoft Inspire, Lixar Azure account manager Stéphane Renette shared the stage with distinguished engineer James Whitaker. James was talking about his recent project to IoT enable his hot tub and bring it online to see all these things in the cloud. In this presentation, you'll see how to IoT enable all of your hot tubs across scale and around the country. Aww, cute puppy. And actually have that data go through. Unfortunately, I don't think there's much of a market for IoT hot tubs, so let's talk about our connected car product instead. You'll see the similarities between the two. Let's get started and get into the details. So let's talk about the requirements of a connected car, which will be very similar to an IoT-enabled hot tub. Of course, we have diagnostics for alerts and notifications. Tracking and geofences is a bit of a stretch for an IoT hot tub, but I could probably make it work. Real-time dashboarding and viewing, as well as an always-on hotspot to ensure it's always connected to the cloud. Of key as well as key fob functionality through a mobile phone, such that someone could lock or unlock their vehicle from afar. Let's take a look at our architecture, but first I want to talk about why we chose Microsoft Azure as our platform. An efficient, scalable, and reliable system that we don't need to worry about or think about. We know it's always going to be on and can handle the loads of millions of messages over time. Let's take a look at the architecture. Fundamentally, we're looking at 3 key things: ingestion of data, processing of the data, and then storage and retrieval for future. Looking at phase 1 of that, we've chosen an IoT hub to bring the data from the device into our system. An IoT hub is just like any other JSON messaging or queuing system, like an event hub, but also allows messages to be sent back to the device. That's a key feature for things like sending alerts, notifications, or the lock of a mobile phone device signal back to the device. Once that data is in, we ensure to use event hubs as well to ensure that any kind of scaling or bursting of the data doesn't bring the system down. Once the data is in, it's key to try and be computationally efficient in the data as we move through the systems. We have a main processing line for real-time data, and then a batch processing for everything that does not need to be real-time. In this case, the real-time data might be turn analytics or real-time alerting or mapping systems to the user. With an event hub, we'll push the data through to batch processing such that it can be pushed out later for a computationally less expensive cost. In terms of phase 3, the data that needs to be stored in databases for future use and auditing, as well as reported out to the system. We use Azure SQL databases and Microsoft storage tables to store our data, but based on what you're getting out of your IoT system, your mileage may vary. Images might be blob storage, for example, might be better. The data goes to HD Insight for future archiving. We use a cache just to improve performance and wrap the entire thing in an API management system, such that web front ends or mobile systems can connect via an enterprise level and flexible system. Let's talk about some design considerations when building our connected IoT platform. Fundamentally, we need to worry about cloud-centric versus edge-centric computing. In this case, cloud-centric refers to bringing all the data and messages back into the cloud to do processing before sending out results back to the systems. In an edge gateway model, the IoT devices themselves might actually do some processing beforehand. Each system has a pro and a con based on what you're looking for. For example, computationally expensive or systems that require additional data should go to the central core to be processed. But for an autonomous car, I would not want a system whereby the data has to go to the core and come back before it decides I need to emergency turn to the right. Main level and batch level processing is something we've talked about previously. We're trying to reduce, in terms of both cost and computational expense, the amount of real-time data to process. Therefore, as the data comes in JSON messages, we parse it out into a real-time stream and a batch processing stream. Using event hubs along the way to ensure that bursts are handled well, we try and process the computationally expensive real-time data as quickly as possible and as small as possible to be pushed back out to the systems. Anything that does not require real time is pushed into a batch process, which is run minutes, hours, days, or weeks afterwards. Storage and durability, of course, is of key importance when dealing with these types of systems. IoT data in real time is necessary for machine learning processes. It's necessary to run the data in auditing and billing systems. To ensure this, we use Microsoft Azure. Systems like SQL databases and blob storage and HD Insight have backup redundancy and geo disaster recovery systems baked right into them as well. And lastly, of course, I cannot talk about this without talking about security. It is key that SSL and other security systems are running across the system of your IoT-enabled platform. The last thing I need is someone with the ability to lock and unlock my car without me knowing it. In terms of performance metrics, we're actually seeing right now for our piloting system more than 2 million messages sent by client every hour, and we're processing that at about a quarter of a second latency. We've chosen a cloud-centric model, so that number's a bit higher. If we needed to do more edge-centric stuff to get that latency down, we possibly could as well. It's never been a better time to try and learn IoT-enabled devices yourself. Grab a quick Raspberry Pi or something equivalent, connect it up to Microsoft Azure, and with a free trial, plenty of how-tos and real-world examples and live documentation, it's super easy to get yourself up and running with a pilot system in a matter of hours or days. Whether it's an IoT-enabled car, an IoT-enabled hot tub, or in the case of my alma mater, a hot tub car that actually works, I look forward to seeing what you do in the future, and thank you very much for your time. My name is Jim Provost, and have a great day.